We are back on Imagine looking at the area of composite figures and trapezoids. So these are figures and shapes that aren't just a normal shape, but a shape that you can kind of break down into shapes that we're a little bit more comfortable and familiar with. So if you're looking at this one, it says that Jonah wants to use both area formulas shown to find the area of a trapezoid. So you can see that we've got the area of a triangle formula and the area of a rectangle formula. So how can he divide the trapezoid to do that? Well, I'm looking to use rectangles and triangles. So does this have a rectangle and a triangle? Nope. Those are two trapezoids. So that's not going to make very much sense when we're looking at this. Does this have a rectangle and a triangle? Well, it has triangles, but it doesn't have rectangles. Does this have rectangles and triangles? It has one rectangle and a couple triangles. That might work. Okay. And the other one has two other weird trapezoids. So I'm going to say probably not. It doesn't have a rectangle or a triangle. So this would probably be my answer, but remember, we still have that math help if we don't get it. So we can look up here and it says right triangles can be used to begin dividing a trapezoid. So if I take off that right triangle on both sides of the trapezoid, that leaves this rectangular center, right? If that's still not making sense, you can see that we've got our triangle here, our rectangle here, and our triangle here. And you can also read through the material. If you're still lost, go ahead and use the teacher. I highly recommend writing down your work in a notebook. If you don't have a notebook, write it down on a piece of paper that you can save for later, because you can use this during the problem solving and the practice and the post quiz so that you actually take in the material instead of just skipping right through it. Okay? Alright, so that would be my first one. I'm going to check it. Again, you can, if you did guess, read or watch through this video and it will help you also see how it's split into triangles and rectangles. So keep in mind that that is also a good resource for you. The next one is a little tricky, and I struggled with this one too. I've done this with a couple of you. It says to drag the correct number of pieces in the box to show how to find the area of the shaded figure in two different ways. Pieces can be rotated to fit. So this one says the pieces, you have to use 5 pieces. Okay, so if I'm cutting this up, I'm going to need to cut it into 5. So the first thing I'm thinking I'm going to do is I'm going to cut off this little triangle here and this little triangle here. That's 2, right? So that's this and another one of those. Okay, and that leaves this shape left, but I still need 3 pieces. So if I cut off a top triangle there and a bottom triangle there, that's 2 more of these, and that's going to leave me with this. So there are my 5 pieces. Does that make sense? I hope so. If that's not making sense, go ahead and go to the math help. Uh-oh, this looks familiar. Okay, they're talking about how you can cut this apart. Now, this one's not necessarily a trapezoid, but you can still cut the shape apart. Okay, the second one has us cutting them into these pieces, right? So this is another way. If I wanted to split it into 4 parts, I could split it. Note that the example is not what the real pieces look like, and they did that on purpose so that you have to actually think it through. So don't feel like they cheated you. This is just so that you truly do understand the material. Okay, and then if you're still not getting it, go ahead and use the Imagine Math teacher. I could just put a random one down here and then go talk to the Imagine Math teacher, but am I being honest with myself? No. So that's probably not the best choice. Now this one says less than, or not equal to 5 pieces. So I could use more pieces or I could use less pieces. That is up to your discretion, because technically this piece, there's 4 of them in here. So I could have, instead of doing it this way, said 1, 2, 3, 4, and then 4 more for that square. 1, 2, 3, 4. And that would be not equal to 5 pieces. That would be equal to 8 pieces. Okay, so that's another option you have. There are multiple right answers to this one. I could have even looked at this and said, oh, that's a triangle, and then this is the middle piece. Oops, triangle, and this is the middle piece, and been done. Okay, so many right answers. It's checking the work, and that's why it took it a little longer. Okay, there's your 1, 2, 3, 4, 5. Okay, then the next, you could have done 1, 2, 3, which is what I ended up doing at the end, or you could have done 1, 2. Okay, so there are several ways we could have done this. Close, and we're moving on. Okay, this next one says that the diagram shows a row of 6 identical tiles, each in the shape of an isosceles trapezoid. Okay, meaning that both of the left and right are equal and the bottom and top are parallel. What is the area of one tile? Okay, so we got to go back to understanding how to find the area of a trapezoid. I'm not sure, so I'm going to go to the math help first.
For the area of a trapezoid is shown below. Area is equal to 1/2 times the height times the sum of the bases. You know that the height is 6 inches, but you do not know the length of either base. Click the trapezoid to see how to find the area.
Oh, well, that's fun. Trying to get back to it. All right, so that was one option. Okay, and sometimes that works, sometimes it doesn't. Now I'm going to move on to the next piece.
Form a parallelogram. You know how to find the area of a parallelogram. Area of a parallelogram equals the base times the height. Click the parallelogram to see how you can use this to find the area of a trapezoid.
Okay, and if that's still not making sense and you've given it a try, go ahead and go to the teacher. But what I am thinking might be my easiest bet is to say, okay, well, this is a parallelogram, right? And there are 1, 2, 3 parallelograms that are equal. Okay, and if I'm looking for the area of one tile, I'm not really worried about the parallelograms, but there are 2 pieces, 2 trapezoids in each parallelogram. And if the area is base times height, I'm going to take my trusty calculator and I'm going to multiply 12 times the height 6, because that is the height of all of these trapezoids together. Okay, and this is the base of that parallelogram, the 2 pieces. So 12 times 6 is 72. Now that's the whole parallelogram, but we know that 2 trapezoids make that parallelogram. So I'm going to divide that by 2 to get the area of just one of the trapezoids, and that's 36. I'm going to come down here and we go with 36 inches squared. Remember, inches squared is important because sometimes they do mess with the units to try to make sure you're paying attention. We're multiplying inches by inches, so that makes it inches squared.